So where we left off is we said that Heckman's goal in developing his theory is to be able to think more carefully about how investments in children early in their lives interact with investments in children later in their lives, right? To consider the life cycle of human development, and to have a richer, more complex understanding of the interplay between what we might think of as children's ability or parents' ability to teach their children and children's environment, right? The quality of investments made in children. So the most general version of this model has many, many different periods of childhood with different critical periods for different types of skills, many, many different types of skills. The model that we're going to be exploring today is going to be really focused on this question of how different stages of child development interact with each other. So in order to do this, the fundamental thing that Heckman wants to develop is what he calls a technology of skill formation, which is to say, we're going to think about how to produce a final product, which is a young adult that has a certain level of skill, by thinking about a variety of different inputs that go into producing that skill. And in particular, we're going to think about those inputs as being investments in the child at different stages in the child's life. So we're going to have a couple of things in this model. Right? We're going to have the parent's ability to invest, or the parent's human capital, which I'll call H. We're going to have the child's ability when they're born, which we can think of as some combination of genetics, prenatal environment, et cetera, right? So we'll call this sigma 0. And then we're going to have investments early in a child's life and later in a child's life. Right, we're just going to explore a model with 2 periods because that'll get us most of the way there with the intuition without us losing our minds. Right, so we're going to have investment in period 1, which we'll call early childhood investment. And we're going to have investment in period 2, which we'll call adolescent investment. Now, Heckman's going to say that fundamentally, the child's eventual human capital, which we'll call H prime, is just going to be some function of all of this stuff, right? So we're going to say H prime is going to depend on H sigma naught I1 and I2. And the first thing he's going to do is he's going to ask, how do different assumptions about the interplay between investments early and later lead to different conclusions about how parents are likely to invest in their children and how different types of public policy are likely to affect the children. So let's think about a couple of possibilities for what this production technology might look like. So the first possibility, maybe the simplest possibility, is maybe investments earlier and later in life fundamentally do the same job and are in some sense interchangeable from each other. So in that case, we're going to have something that looks like this. H prime is equal to H times sigma naught times A1 times I1 plus A2 times I2 all to the B. So what's this telling me? It's telling me that if I reduce my investment in a child by 1 unit in period 1, I could increase my investment in a child by some amount in period 2, have this interior thing here stay exactly the same. So to help us understand this, let's pick some specific numbers, right, instead of these A1s and A2s. Let's say that I have A1 equal to 2, A1 equal to 1, and B equal to 1, just to keep things simple. Then I would say H prime is equal to H times sigma naught times 2 times I1 plus I2, right, all to the 1. And if I wanted to think about what are all the combinations of I1 and I2 that would get me to a certain level of H prime, I'd be able to think about this technology of skill formation exactly the same way that we think about the technology of production if we're thinking about a farm, right? And in other words, we can ask, if I want to say what's the right amount of I1 and I2 to choose, I just have to ask, what combination, what's the cheapest combination of I1 and I2 for a particular family that gets me to the end result that I care about. So what would that look like? I'd say that my MRTS, right, I could say the change in H prime that results in a change in I1, right? How much do I increase my child's human capital by investing in them in period 1 is just going to be H times sigma naught times 2, right? dH prime di2 is just going to be H times sigma naught times 1. Right? So as a result, my MRTS, which is equal to dH prime di1 over dH prime di2, is just going to be 2H sigma naught over 1H sigma naught, which just equals 2. So what's this telling us? It's telling us that if I drew a graph with all of my combinations of I1 and I2 that produce a certain amount of human capital, it's just going to be a straight line with a slope of 2. What it tells me practically is that if I'm a parent and I'm trying to decide, I love my child, I'm trying to give them the best life possible, and I'm trying to decide whether I ought to prioritize investing in my kid when they're young or investing in my kid when they're an adolescent, I'm just going to pick whichever period of time is most convenient for me, right? So if the cost to me of giving up $1 of consumption in period 1 is more than twice as high as the cost to me of giving up $1 of consumption when my kid's older, when my kid's an adolescent, period 2, I'm going to invest that dollar in period 2, right? I'll invest $2 in period 2 to make up for the $1 I could have invested in period 1. If that isn't the case, then I'll invest in period 1 rather than in period 2, right? So if this is the case, if in some sense early and later life investments are perfect substitutes and are effectively interchangeable with each other, then Becker's model is basically correct, right? We don't need to worry that much about periods of life or life stages because we can just leave it up to the parents, right, to invest in their children, or leave it up to policymakers who are designing preschools, elementary schools, etc., to invest in children whenever has the highest return for the child's development and whenever is cheapest and most convenient for the school itself. And if we think about a model like this and we ask a question like, why is it that the cognitive benefits of peri-preschool faded out, right? Why is it that we saw these big gains right after kids were in preschool that disappeared over the course of several more years? A simple conclusion would be a Becker conclusion that says, well, we gave this big benefit to kids when they were young, so parents felt less of a need to invest in their children when those children were older, right? They took some of the money they would have spent trying to improve their kids' well-being or the resources, time, attention, suffering, etc., and instead of spending it on the kids' human capital, they used it to take the kids out to ice cream more often, have more fun as a family, treat themselves to nicer stuff, etc., right? And so those gains disappeared because essentially parents reallocated their resources. So what about the other extreme? What if instead of being perfect substitutes, investments early in life and later in life were perfect complements, right? In other words, what if we imagined that investing in your child's education, giving a child a high-quality preschool education, is only going to be useful to them if it's followed up by a sufficiently high-quality high school education, and conversely, a high-quality high school education is only useful for children who have already received high-quality preschool. In other words, what if instead of having an isoquant that looks like this, right, where I'm always able to compensate for a reduction in early childhood education with an increase in later childhood education at some exchange rate, what if I had an isoquant that looks like this? Oh, terrible. Those lines are supposed to be straight, not the scrawlings of a deranged person, right? What if I had an isoquant that looks like this? So that there's absolutely no amount of later life investment that would compensate for losing some early life investment, and absolutely no early life investment that would compensate for insufficient later life investment. From a functional form perspective, what this would mean is we'd have something like H prime is equal to H times sigma naught times the minimum of, let's say, I1 over A1 and I2 over A2 to the B. Right? So again, to make this more concrete, we could imagine A1 equals 2, A2 equals 1, B equals 1. We could just say H prime equals H times sigma naught times the minimum, right, I1 over 2 and I2. So regardless of when it's convenient for us to invest in our children, we're always going to want to have I1 over 2 equal to I2, right? Otherwise, if we had I1 over 2 greater than I2, we're investing in our children in their early life in a way that's going to be totally unproductive, right? Because we're not following it up with later life investments. If I1 over 2 was less than I2, we'd be investing in our children later in life in ways that are totally unproductive, right? Or in other words, because in this case we'd say that, you know, a child needs twice as much investment early as late, we would just say I2 equals 2 times I2. I'm sorry, I1 equals 2 times I2. Right, so this is the opposite extreme, where instead of saying that I1 and I2, right, investment early and late are interchangeable, we'd say that investment early and late are fundamentally only useful together, right, and can't compensate for each other whatsoever. Now, I would strongly suspect that the reality is somewhere in between those two extremes. In other words, that it is possible to make up for a low level of investment early in childhood by increasing investment later, but that doing so is difficult, and that the larger the disadvantages in early childhood education, the more effort, cost, and frustration it'll require in order to achieve a certain level of human capital later in life. In other words, if we think about a child who hasn't learned to read by the time that they're 10, you could eventually teach, you know, that child could have sufficient dedication, sufficient resources devoted to their education to be college ready by the time they graduate from high school, but getting that child to that point is going to take a lot more effort than if the child had gotten some of those early skills when they were younger. So if we want a model like that, right, something that's in between these extremes of perfect substitutes, total interchangeability, and perfect complements, complete non-compatibility, right, no ability to make up for early childhood deficits, we're going to want something where I1 and I2 are in between complements and substitutes. The way that Heckman does this in the paper, which I'm just going to show you so you can map on what we're doing in class to what's in the paper, is he uses what's called a CES production function, or constant elasticity of substitution, what Heckman actually uses. And the CES production function is going to have a form like H prime equal H times sigma naught, all times A1 times I1 to the B, plus A2 times I2 to the B, all to the 1 over B. Now, the thing that's cool about this production function is that depending on the value of B, this ranges all the way from acting like perfect substitutes to acting like perfect complements or to acting like anything in between. So it's a maximally flexible functional form that allows us to not make any strong stances about just how easy it is to make up for low levels of early child investment later in childhood. But for our purposes, it's a little bit too complicated, a little bit too much of a mess to actually deal with. So what we're going to use is Cobb-Douglas. In other words, we're going to say that your human capital investment as an adult is going to be a function of your parents' human capital, right? How easy it is for them to teach you or guide you through school. Sigma naught times I1 to the A times I2 to the B, where A plus B are less than or equal to 1, right? In other words, we're still, overall, if you increase I1 and I2 together, you're going to get a little bit less increased earnings potential from large amounts of human capital investment than smaller amounts of human capital investment. Cool. So again, to make this concrete, let's pick A equals B equals 1/2, and then we can say H prime is going to equal H sigma naught times I1 to the 1/2 times I2 to the 1/2. Lovely. So if this is our production technology, what's that going to imply about the productivity of investments in early childhood or later childhood? Well, we can think about this by taking our partial derivatives, right? So we can say dh prime di1 is going to equal h times sigma naught times 1/2 I1 to the negative 1/2 times I2, right? This is going to equal h times sigma naught times I2 over I1 all to the 1/2, right? And likewise, we can say that the h prime di2 is going to equal h sigma naught times 1/2 I1 to the 1/2 times I2 to the negative 1/2, right, which is going to equal h times sigma naught times I1 over I2 all to the 1/2. So what's this telling us? It's telling us that, maybe unsurprisingly, investments in early or later childhood education are going to be more productive, increase our human capital more, if we have high ability, right? High ability level at birth, and if our parent is highly educated or has lots of skills, so that it's easier for them to teach us when we're young, right? And if we thought about these investments as coming through the school system rather than our parents, if the school we're going to is very good, would fit in there instead. But we're also going to say that investments in early childhood are going to be more productive the larger our investments are going to be in later childhood, and less productive the more we've already invested in early childhood, right? In other words, in order for our early childhood investments to be really effective, really productive, they ought to be paired with follow-up investments later, right? Going to a really good preschool is going to help you more if you go to a really good high school. And exactly in the same way, right, the productivity of our investments later in life, right, our high school investments, are going to be more productive the more and higher quality our preschool education was, right, the larger I1 was. So high school investments have diminishing returns, right, each additional dollar is a little less effective than the one before it, but they're also going to be more productive the better our elementary school was, right? In terms of our isoquants, this is going to mean that we've got an I1 and an I2, where our isoquant's going to look something like this, right? Where the amount of high school investment it's going to take to make up for loss of early childhood investment is going to be very large when we've got fairly low levels of early child investment, right? When we're well below grade level coming out of preschool. But the amount of high school investment it will take to make up for a decline in early childhood investment is going to be pretty small when we've got lots of early childhood investment and lower levels of high school investment, right? Awesome. So what I'm going to do next is we're going to take this basic framework, right, this technology of skill formation, and we're going to use it to think through problems faced by parents deciding how much to invest in their children at different points in the life stage. That's going to allow us to think about how our early childhood experiences going to influence the decision of how much to invest when a child is an adolescent, and how much our expectations about the future going to affect parents' decisions about how much to invest when children are young.